Hello everyone. In this video, we're going to see factorial using recursion. So what's a factorial? If you're given an integer n and you are asked to find the factorial for n, then it is just a multiplication of n and n minus 1 and n minus 2 up to 1. Or you can, as in slide you see, 1 cross 2 cross 3 up to n. So if you are given a 7 factorial, and 7 factorial is nothing but 1 cross 2 cross 3 up to 7. So this way of finding is said to be factorial. So in case of recursive factorial finding, you have to identify a subproblem. So in here you have provided, this is the subproblem identification. If you see, so if you are asked to find n factorial, you have to just multiply n with the n minus 1 factorial. So now we have a n factorial which is represented in this format. So we just have to now worry about finding factorial for n minus 1, not for n. So this is called subproblem. This one is called subproblem. For example, if you are asked to find 7 factorial, so it is nothing but 7 cross 6 factorial. 6 factorial is nothing but 1 to 6 multiplication of 1 to 6 here. So this is 7 cross this whole thing is a 6 factorial. This one. So if you are asked to find 7 factorial, now we are represent this problem in terms of n minus 1 factorial, that is 6 factorial. So we just have to find 6 factorial now. So for finding 6 factorial, it is nothing but 6 cross 5 factorial. So the subproblem recurses. For example, if you are asked to find 5 factorial, which can be represented in terms of 5 cross 4 factorial. So now 5 factorial needs answer for 4 factorial, but 5 is available, but we don't have the answer for 4 factorial. So we are waiting for this one to get this answer. 4 factorial needs 4 cross 3 factorial, so we are waiting for 3 factorial. 3 factorial will need 3 cross 2 factorial, that means it needs 2 factorial. 2 factorial will need 2 cross 1 factorial, it is waiting for 1 factorial. 1 factorial value is 1. So we are stopping this recursive logic at this point where the number reaches 1 factorial. So this 1 factorial, so all are, if you see here, all are waiting this inner wait. So 5 is waiting for 4 factorial, 4 factorial is waiting for the value of 3 factorial, 3 factorial is waiting for 2 factorial value, 2 factorial is waiting for 1 factorial, and 1 factorial will not wait for anybody. So that is called stopping condition. Here stopping condition is 1 factorial value is 1. So you should not recurse further. So 1 factorial will return the value here. That means the waiting of 2 factorial is over, because value of 1 factorial is 1. So 2 factorial got the value of 1 factorial. Once it gets the value of 1 factorial, it will perform the operation 2 cross 1 factorial. It's nothing but 2 into 1. That will be performed and that will be returned here. So the waiting of 3 factorial will be over. Once the waiting of 3 factorial is over, 3 factorial will give the value here. So then waiting of 4 factorial is over. Once the 4 factorial's value is computed, then the 4 factorial value will be available for 5 factorial finding. So then it will also be over. So it needs a recursive logic stopping condition. That's a very important thing in recursive logic writing. I will show this with the code. Suppose we are finding 5 factorial. So I am just putting a print. We are calling a function f. F is a function which is going to find a factorial. Now f is a function I am writing which gets number n. So I am passing 5 to this one. So objective is we are finding value for 5 factorial. This is a function. The function body is like this. So I am passing this value 5 to this one. So what we have to return, this one will return. So if you see this one, 5 factorial will return 5 cross 4 factorial. You see, this way. So it is nothing but return n cross n minus 1 factorial. So we need to find the factorial for this. So just we have to pass this value to the same function. So this is called recursive function call, a function which is calling itself. So from the body I am calling the same function, but the value is different, so it is opening a new chapter. Say for example, we are passing 5 factorial here. 5 factorial function is running where n equal to 5. So it is waiting for n is 5 into this function call. So this function call should end to get the value in the right side of this star. So this originated, that means this is waiting. This will wait. This will wait because it is not over. It has to return this value n cross this value. But this is a new function call. It has originated. So it will pass 4 here. So it is, the earlier one is waiting. Now the new function call is running. N equal to 4. 4 will be 4 cross 3 factorial. Again now one more function call started. So it is 3 will come here. 3 is when 3 cross 2 factorial. One more 2 comes here. N equal to 2. So 2 cross 1 factorial. So when n becomes 1, what we have to do? We have to start give the value to this one. So if 1 factorial is arrived at, its value is 1. That means you have to return the value to the called function. Who called it? 2 factorial called it. Okay. So if n equal to 1, this is where we are doing the stopping criteria. Stopping criteria is if n factorial is coming for the value of n equal to 1, then we have to return 1. That's it. So this code will do the job. So when n reaches 1, it will return 1. To whom it will return? To the called function. Who called a 1 factorial? 2 factorial called. So 1 is returned here only. So when 2 factorial got it means 2 into 1. It will return. But where it will return? The 2 factorial will return to 3 factorial because 3 factorial function only called this 2 factorial. So when a 3 factorial will get the value, it is 3 into 2, which is a 2 factorial value, that is 6. So 3 factorial is going to return. To whom it will return? To the function 4 factorial, where n equal to 4 factorial, because that's only called as 3 factorial. So the recursively, I told you, I just put a tab space here. So 5 is waiting for 4. So here 1 just returns here. Once 2 is computed, 2 returns here. Once this 3 factorial is computed, 3 factorial is returned here. Once this is completed, it will be returned here. Then the 5 factorial value is got, it will be returned to the main. Who called it from the first time? It will return to the normal main program. Okay. So this will do the job. You see, 120, which is a 5 factorial. So this is the logic to write recursive factorial. So I can get input anything different way. Say if I say int, if I say a num a equal to int of input, I just put, we can just pass that value, a value here. So if I am waiting for input here, 8 I am putting. Eight factorial, four zero 320. Six factorial, 7 factorial, 8 factorial, 15 factorial, So if you go for 50 factorial, 50 factorial, so it just goes up to big numbers. I hope you understood how this logic of writing recursive function for finding factorial works. Thank you.